In this video, we're using spectrum view to characterize the phase difference between a pair of radar pulses. I've got a 20 microsecond wide 3.85 gigahertz radar pulse being applied to channel 1 and to channel 2. But for the pulse train being applied to channel 2, the carrier phase is being stepped between 4 different phase offset values with respect to the pulse being applied to channel 1. To set up these displays, we turn on spectrum view first for channel 1. In this case, we're turning on the normal spectrum trace so we can see the spectral content of the pulse itself. We see our carrier frequency at 3.85 gigahertz. And then we're also turning on the phase deviation versus time plot, which is shown here. Now, when looking at phase versus time, you have to establish a reference point, as phase is always relative. So the phase reference typically is at the trigger point, and it will be set to 0 degrees. Now in our case, the trigger point is right at the beginning of the pulse, and it's before the pulse has established its full amplitude. So what we did is we choose to move the reference point, still keep it at 0 degrees, but we move it to a location that's defined by the cursor. So I'd put a cursor about in the middle of the pulse and said, that's the point that I want to be 0 degrees. So that now becomes our phase reference for that pulse. And now we can see that because this is an unmodulated pulse, the phase versus time is flat, or essentially 0 degrees across the duration of that pulse. Now normally this phase reference needs to be set on every channel. However, since we want to make phase measurements with respect to channel 1, we're choosing to make the channel 1 phase versus time the master reference by checking this box. So now any other spectrum view channel that is turned on, its phase is going to be measured with respect to the channel 1 phase. And we can see this by bringing up the phase reference settings for the channel 2 phase versus time, and it's telling us that channel 1 is currently defined as the master phase. So now we know that this channel 2 phase deviation versus time plot is showing me phased with respect to the carrier in channel 1. I'm also making use of the new call-out feature to create these two bookmarks, which will essentially give me live readouts of a waveform value across these two waveforms. So I can now see the phases that the channel 2 carrier frequency is stepping through. And I can see about a 90 degree, a 20 degree, a 40 degree, and a 60 degree phase change that we're alternating through on the channel 2 pulse train. Now it might be handy to overlay the channel 1 and channel 2 phase deviation plots to make it easy to compare their phase differences over time. And you can quite easily do that by taking the badge for channel 1 phase versus time and dropping it on top of the channel 2 phase versus time, and now those two plots are laid on top of each other, and I can now see those differences between those phases very clearly. This has been a quick look at how to look at the phase difference between two separate channels and even overlay those phase versus time plots to understand how that phase is changing across those channels.